Well, what good's a unit circle if you're not going to use it, right? Let's find the value of each one of these, and we're going to try to go from memory on a lot of this, but I am going to pull out the unit circle as a reference. So there's going to be a lot of this back and forth. Here we go. I want to find the cosine of pi over 2. Cosine is the y value. Pi over 2 is up here. Here we go, I'm drawing it. I'm going to be pointing at this a lot. Got the target. Cosine of pi over 2. Pi over 2 is up here. The x value is 0. All right, tangent of 4 pi over 3. Well, tangent of 4 pi over 3, that's around here somewhere. Feel free to grab your unit circle if you need to. On mine, it is this. 4 pi over 3, tangent is, well, square root of 3. Square root of 3. Cosine of negative pi over 4. Oh my goodness, what are we going to do? We have a negative angle. Oh no. Okay, so instead of going to pi over 4, we're going to go the opposite direction, but we're going to go the same length. So instead of going this distance, we're going to go this distance here. It's basically the equivalent of 7 pi over 4. 7 pi over 4. They did ask for the cosine, and that would be square root of 2 over 2, which is exactly the same as this one, but I wanted it here. So square root of 2 over 2. All right. Secant. Oh, well, let's find. Where's secant? Where's secant? Oh, where's secant? Oh, I don't have secant. Oh, yeah, I do. Secant is 1 over cosine. So let's deal with cosine, and then we're going to reciprocate it. So let's just pretend for a second that this says cosine. All right, fine. Cosine of pi over 4. Cosine of pi over 4 is square root of 2 over 2. So I don't want square root of 2 over 2. I want the reciprocal of that. I want 2 over the square root of 2, which, by the way, divides to be square root of 2, because the square root of 2 goes into 2 square root of 2 times, because this times this gives me that. Just saying. Okay? Let's move on. Let's go through these next problems a little bit faster and hopefully by memory. Pi over 6 is in the first position here. And cosine starts with 1 square root 3 over 2. There you go. Don't make it harder than it is. Pi over 3 is right here. And we're dealing with sine. Sine counts back with 1 square root 3 over 2. Man, getting a lot of the same answers. Tangent of 17 pi over 6. Well, first of all, that's ridiculously large. So we're going to modify that. So this is one of those situations where you've gone around the circle more than once. So if we've gone around the circle exactly once, then we're at 2 pi. Well, 17 over 6 is bigger than 2. 17 over 6 is significantly bigger than 2. So what I'm really going to be dealing with is the tangent of something else. It is a fraction. It does have a pi in it. So if I was to travel around this unit circle, 17 over 6 times pi, you'll see what I mean. So 1 over 6, 2, we're going to get to 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sixths is 2. 12, 13, 14, 15, 16, 17. It takes me to 5 pi over 6. I'm really dealing with 5 pi over 6. And here's another way of doing it with a scrap piece of paper. With this 17 over 6, you can divide that out, and you're going to have 2 and 5 sixths. Well, I don't need the 2 because that just takes me around the circle once. I just need the 5 6. I'm ignoring the pi in this. This can happen in your head. Okay, I need the tangent of 5 pi over 6. Tangent of 5 pi over 6 is negative square root of 3 over 3. All right, cotangent of 5 pi over 6. This is actually the exact same answer, only it is reciprocated. So it is negative 3 over the square root of 3, and we're in the same situation as we had above, where I need to simplify this. Now, if you're a little confused on why that is, we could rationalize this denominator. Feel free. So if you're stuck on where did this come from and how's he going to get that, here it is. 3 divided by the square root of 3. Let's multiply by the square root of 3 over the square root of 3. Here's another way of doing it. And we'd have 3 square root of 3 over 3. They'd cancel. That's how we do it. It's one of the many ways. All right, 4 more problems in this section. Let's go fast. Negative 5 pi over 3. Negative 5 pi over 3 is going in the opposite direction. And so positive 5 pi over 3 is here if I went this way. But now I'm going to go the other way, and I end up here at positive pi over 3. So if you want to rewrite it, you could. You could call it cosine of pi over 3. And cosine of pi over 3, and cosine starts with 1, square root 3 over 2, square root 2 over 2, 1/2. So this is equal to 1/2. There we go. I should put equal marks in this so you know that these are answers. Not that you didn't know that. Tangent of 19 pi. Oh my goodness. Okay, well, if I wanted to grab a scrap piece of paper, again, I'll wear this paper out. 19 is a lot. This is really 2 times something and then a little bit extra. Okay? This is 18 plus 1. Why did I use 2? Because every time I travel 2 pi, I have gone all the way around the circle. So if I go 2 pi, 4 pi, 6 pi, 8 pi, you see what I mean? 18 pi, and then another pi. I'm just back here. I'm at 1. So this is the equivalent of asking for the tangent of pi. The tangent at pi, that would be over here. That is sine divided by cosine. It's the y divided by the x. So it would be 0 divided by 1, which is 0. Okay. 8 pi over 3, that is bigger than 2 pi. So 8/3, we'll divide that. We'll see how many times 3 goes into 8. Oh, that goes in twice. How convenient. 2 2/3. So what I'm really dealing with is that. Again, all this can happen in your head. So I really have the sine of 2 pi over 3. All right, 2 pi over 3 would be right here. Boy, I'm making a mess of this thing. I'm trying to do it in my head on paper. Let's not. If I didn't know this, I would say sine counts back with 1, square root 3 over 2. There it is. And it is positive in this quadrant. So, square root 3 over 2. All right, last one in this section, negative 2 pi over 3. Let's ignore the cosecant. Let's deal with sine. Let's find sine first. And it might behoove us to not treat it like a negative. Let's treat it like a positive. So negative 2/3 would take me, or positive 2/3 would take me here. Negative 2/3 will take me there. It takes me to this place that is a mirror image over the x-axis. So it takes me there to 4/3 pi. So I wrote sine. I should not have written that. That should be cosecant, not sine. I don't want to lose sight of what I'm doing. I do need the sine value. I apologize if I made you write something that you didn't need to write yet. So I'm going to find the sine value at 4 pi over 3, and that would be negative square root of 3 over 2, but I'm dealing with cosecant, so I'm going to reciprocate that. I'll flip it over. So it's negative 2 over the square root of 3. Negative 2 over the square root of 3. This is correct. I'm going to simplify. I'm going to rationalize the denominator. It's not always necessary, but I just feel like it. I'm just in a rationalizing the denominator kind of mood so I can run out of the box. There we go, thinking outside the box.